All right. So 5.4 u-substitution. All right. So up to this point, we've only figured out, okay, I can do the integral of sine of x, right? But we don't know how to do something like that, right? Right. So what we're going to do now is figure that out. How do we exactly come up with a integral or an antiderivative for a function like that? Right. These are all composite functions, right? You have a function built inside of another function. All right. So what we're going to need to kind of figure out is you're going to have a function built inside of another function, right? So we need to kind of get good at recognizing what is your innermost function. That's going to help us figure out exactly how to find the antiderivative. Right? So how to come up with the innermost function is usually if it's built inside exponents, built inside of sine. And another way you can look at it is the innermost function, his derivative will also be present somewhere. All right? So if you think that, okay, maybe this is my innermost function, do I see his derivative somewhere else? Right? So just kind of keep that in mind. Look for the innermost function, and then his derivative should be present. Okay, so if I'm looking at the integral of x squared plus 1 squared times 2x dx, right, I really kind of have two different functions here, right? I have x squared plus 1 squared would be 1, and then the other one would be 2x, right? Those are kind of the two big ones looking at me. So out of those two, right, which one is built more inside? It has more outside parts. X squared plus 1, right? All right. So what I'm going to do is I'm going to call that u. So u is equal to x squared plus 1. All right, because x squared plus 1 is built inside of the square, right? All right, so the rule says if you have your inside function, right, when you take his derivative should also be present, right? So what we're going to be doing is you are taking the derivative with respect to x, right? So when I take the derivative of u, I get du over dx, right? Now, when I take the derivative of x squared plus 1, what do you get? 2x, right? All right, and what I'm going to do, I'm going to multiply the dx over. So you get du is equal to 2x dx. Okay. Now, we've already figured out that the u part is x squared plus 1, right? Now that I know what du is equal to, right, so that's the derivative of u, is equal to 2x dx. Do you see how this is right here? All right, so what this is going to do, du is going to take the place of 2x dx. And then u is going to take the place of x squared plus 1. All right, so how you rewrite this is, instead of x squared plus 1 squared, I'm going to replace the x squared with plus 1 with a u. So I have u squared. All right, and then I'm going to replace 2x dx with du. Okay. Now everything is the same, right? I still have x squared plus 1. I just replaced it with u. I still have 2x dx, but I just replaced it with du, right? See how this is like blob squared, right? So now what, instead of having to, you know, because we don't have like a product or a quotient rule for integrals, right? So this is your kind of your rule for that. So instead of doing that, now all I have to do is just figure out the integral or antiderivative of u squared. What would that be? 1/3 u cubed, right, plus c, right? Now what do we know u is? X squared plus 1. So I have 1/3 x squared plus 1 cubed plus c. There's your answer. Once you get, like, you do more and you get the kind of hang of it, they're actually pretty quick. All right, so if you check your answer, right, bring the 3 down. 3 over times 1/3 is 1. So you have x squared plus 1 squared times the derivative of the inside, which would be 2x. All right? So again, you want to look for the innermost function. All right, number 2, I got 3x cubed times sine of 2x to the 4th plus 1. All right, what I want to do first, I want to put my constant here out front. So that's going to give me, let's not do that. I got 3 integral of x cubed sine of 2x to the 4th plus 1. So, yeah, you're finding the antiderivative. This is just a technique for finding antiderivatives. All right, so I have x cubed, I have sine of the blob, and then I have 2x to the 4th plus 1. So out of those 3, which one do you think is the innermost? Right. Yes. Yeah. You can think of it like that. This is called like an indefinite integral. When you have numbers there, that's a definite integral. Yeah, you're only looking at a certain piece, where this is like the entire everywhere. Okay, so what would du be equal to? No. What's the derivative of this? 8x cubed dx, right? Okay, so I have x cubed and I have dx, right? What I don't have is the 8, right? I have no 8 here. All right, so this is what you have to call when you're correcting the problem. So if it doesn't match up exactly with what you have, x cubed dx, right? We're going to move this 8 to the other side. So how would you move the 8 to the other side? Divide it, right? So what I have now is 1/8 du is equal to x cubed dx. Okay? So now this is going to take the place of x cubed and dx. U is going to take the place here. And then all I'm left with is going to be sine. All right? So I have the 3 that was out front originally, right? Now I have this 1/8. This is another constant that I can put out front. All right, so I'm going to put it out front like that. integral sign, I'm left with sine of u du, right? U is replaced by 2x to the 4th plus 1, and then du is equal to x cubed and dx. So I have everything covered. Now all I have to do is figure out the antiderivative for sine, which would be what? Negative cosine, right? So I have 3/8, because I can multiply those two guys together. I have negative cosine of u plus c, right? And I know that u is what? There you go. So the x cubed dx is replaced with du, right? So when you write du here, it's the same thing as x cubed dx. So that takes the place of that and that, right? What do you mean? So when you integrate, right, this is like sine of x dx, right? When we integrate, that kind of goes away, right? But by doing u and du, it takes up all these other pieces that you have there. Yes.